Hari Om. Let us proceed to the next topic in matrices, that is elementary row operations. So here we have three different types of operations. First of them is interchange of rows. So suppose we have a matrix 3, 2, 4, 5, 6, 7. So this is our first row, this is our second row. If we interchange R1 with R2, remember this symbol, for interchange we use this symbol. So on interchanging R1 and R2, our matrix will now become 5, 6, 7, 3, 2, 4. This is a type of elementary row operation. Now in the second type, what happens? So we can multiply any single row with a given constant. So let that constant be A. Suppose we have a matrix 5, 4, 3, 2, 1, 0. We have three rows R1, R2, R3. If we use this operation as R1 changed to R1 into 4, so our matrix will become, see, only R1 is going to change. R2 and R3 will be as they are. So R2 will be 3, 2, R3 will be 1, 0. R1 will become R1 into 4. So 5 into 4, 20. 4 into 4, 16. So this is our new matrix. This is the second type of elementary row operation. We have multiplied a number. Similarly, we can divide a number also. Now from this matrix, if we apply R2, change to R2 divided by 3. So our matrix will become, as you can see, R2 is going to change. R1 will stay as it is. R2 will be changed to R2 by 3. So 3 by 3 is 1. 2 by 3, 1, 0. The third row will remain as it is. This is the second type of elementary row operation. Now coming to the third type. In third type, what we are going to do is, we will add a given row with some multiple of the other row. So we will add the given row, the row which we want to change, we will add that row with some multiple of some other row. For example, suppose we have 1, 2, 3, 2, 1, 0, 3, 1, 2. And we can apply R1 change to, so R1 is changing to R1 plus 2 into R2. So this is a type of third one. So we are adding R1 with twice the values of R2. So our matrix will become, as you can see, only R1 is changing. So R2 and R3 will stay as they are. R1 will become, so 1 plus 2 into R2. So 1 plus 2 into 2 is 4. So this is 5. Similarly, 2 plus 2 into 1. So 2 plus 2 into 1. So 4. 3 plus 2 into 0. So 3. So this is our new matrix. So 5, 4, 3, 2, 1, 0, 3, 1, 2. So using elementary row transformation, we have got this matrix from the parent matrix. So these two matrices are said to be related to each other. They are not equal, but they are related to each other. That is, we can obtain this matrix from the first one and vice versa. Now this elementary row transformation, we have only transferred rows. You can also transfer things or change the things, multiply the things using column. If you change something in columns, that will be called as elementary column transformations or elementary column operations. Now proceeding to the next topic, we have invertible matrices. So suppose we have two square matrices of same order. Let us take, for example, 3 cross 3. So A is a matrix of order 3 cross 3 and B is another matrix of order 3 cross 3. Let us also take the identity matrix of order 3 cross 3. What is the identity matrix? Remind yourself, our identity matrix was something like this. Means all the principal diagonal elements are 1 except that everything else is 0. So this is identity matrix of order 3 cross 3. So we have 3 matrices. We will represent identity with I. Now, if on multiplying these 2 matrices, so if A into B gives us I and B into A also gives us I, so if on multiplying A and B we get the identity matrix, and on multiplying B and A we also get identity matrix. So A and B are called as inverses of each other. So we can say that the inverse of A is B and the inverse of B is A. So you have to set, means both the conditions have to be satisfied. A into B should be I, B into A should be I. Don't think that both of the multiplication are going to be same. In simple numbers, in simple algebra, 2 into 3 was same as 3 into 2. But in case of matrix, A into B is not equal to B into A. So if both are equal and the result is identity matrix, then A is the inverse of B and B is the inverse of A. So using elementary row transformation, questions will come to find the inverse of a given matrix. Okay, so let's take an example and see how to find the inverse of a matrix. There is a given procedure. You should and you must follow this procedure to find the inverse. Alright, so let's take an example. For example, so suppose this is the given matrix and we want to find A inverse. So A is 2 0 minus 1 5 1 0 0 1 3 and we want to find A inverse. So our procedure is we will start from A is equal to I into A. As you know, if you multiply identity matrix with any matrix, the result will be same. So let us write the matrices. A is 2 0 minus 1 5 1 0 0 1 3 is equal to I is, since we are using a 3 cross 3 matrix, we have to consider a 3 cross 3 identity matrix into A. Let A be like this. So the concept here is, by using elementary row transformations, we will change this to identity matrix, and as we are changing this to identity matrix, the identity matrix will also change to something. So now if our LHS somehow becomes I, we will get a matrix into A. Now what this matrix will be? This will be the inverse of A. So this is our concept. So let's start, and here there is some specific procedures. What you have to do is, you have to make the first element 1. This element you have to make 1. How to make this 1? By dividing it with whatever number is there. Suppose if here in this case we have 2. So we will divide 2 from the whole row. So R1 change to R1 divided by 2. Our concept is we will make this 1, then using this 1 we will make R2 and R3 0, these two elements 0, then we will make this 1 and using that we will make the other two elements of that column 0, then we will make the third row third column element, last element 1, using that we will make other two elements of that column 0. Hence we will get 1 0 0 0 1 0 0 0 1. And whatever matrix we will get here will be A inverse. So let us follow the first transformation. So since we have 2 here, we have to divide whole R1 with 2. So our this equation will become 1 0 minus 1 by 2 1 by 2 0 0 A, and everything else as it is. Here we have changed only R1. You follow this procedure only. This is the way to calculate the inverse. Now our first element is 1 and we have to make these two 0. As you can see, the third one is already 0. So our work has been a bit easier. Now we have to make R2 0. How to do that? You know, if I use 5 minus 5 into 1, I will get 0. So whatever element is here, 5 is in R2. So I have to apply R2 minus R2 5 into R1. R2 minus 5 times R1. So let us change R2 to R2 minus 5 times R1. By practice you can get to know these things. So the matrix will become, now since we are changing R2, R1 and R3 will be same. So just write that beforehand. So half 0 0 0 0 1. Now in R2 we have 5. So R2 change to, so 5 will change to 5 minus 5 into 1. So 5 minus 5, it will be 0. This element will be 1 changed to 1 minus 5 times 0. So 1 minus 0 is 1. Here we have 0. So 0 minus 5 times minus half. So 0 plus 5 by 2. So this will be 5 by 2. Similarly this side. So 0, whatever elementary row operation we are applying will apply to the complete row, means both the matrices. So here we will get 0 minus 5 into R1, that is half. So minus 5 by 2. Here similarly 1 minus 5 times 0 is 1. 0 minus 5 times 0 is 0. Alright, now you can see we have got the first column 1 0 0. Okay. Now our next step is to make the middle number, this one 1. Since it is already 1, we won't do it here. But if it would have been 2 or something else, then you can divide the whole row by 2 to make this number 1, as we have done in this step. Next, let us come to the next step. So using this one, we have to make the other two 0. As you can see, the first element is already 0. We have to make this one 0. So this is R3. How can we make this 0? If we subtract 1 and 1, this will become 0. So let us change R3 to R3 minus R2. So R3 is changed to R3 minus R2. So our equation will become, as you can see, only R3 is changing. R1 and R2 will remain same. So 1 0 minus half, half 0 0, 0 1 5 by 2, minus 5 by 2, 1 0. Now R3 is changed to R3 minus R2. So R3 minus R2, 0 minus 0, 0, 1 minus 1, 0, 3 minus 5 by 2. So 3 minus 5 by 2 is 1 by 2. 0 minus 5 by 2 is 5 by 2. 0 minus 1, minus 1, 1 minus 0, 1. Alright, so second step is also over. Now in the third step, we want the last element, this half, to be 1. So how to do that? As you know, whatever number is there, divide by the whole row. So R3 change to R3 divided by half. So our equation will become, since R3 is getting changed, all others will remain same. So 1 0 minus half, 0 1 5 by 2, half 0 0, minus 5 by 2 1 0. So R3 changed to R3 by half. So 0 divided by half is 0, 0 divided by half is 0, half divided by half is 1, 5 by 2 divided by half is 5, minus 1 divided by half is minus 2, 1 divided by half is 2. Now using this one, we have to make the other two elements 0. So how to do that? Let us follow the same procedure. So now we have to make the element minus half as 0. How can that be made? So let us change R1 to, so R1 is changed to R1 plus half of R3. You have to remember that using this one, you have to make the other elements 0. Don't use themselves only. So R1 is changed to R1 plus half of R3. These elementary row operations that I am applying will come to you with practice. So practice as much as you can. So our equation will become, since R1 is changing, R2 and R3 will remain same. So 0, 1, 5 by 2, minus 5 by 2, 1, 0, 0, 0, 1, 5, minus 2, 2. Now R1 changed to R1 plus half of R3. So 1 plus half of 0 is 1. 0 plus half of 0 is 0. Minus half plus half of 1 is 0. Half plus half of 5 is 6 by 2, 3. 0 plus half of minus 2 is minus 1. 0 plus half of 2 is 1. Now only our last step is left. So we have to make this 0 using this one. So this is R2. So R2 changed to R2 minus. Here I have taken plus because this number was negative. If we add it with something, it will get to 0. This number is positive. So we have to subtract it by something. So R2 minus 5 by 2 times R3. So let's find the values. R2 is changing, so R1 and R3 will be same. So 3 minus 1, 1, 5 minus 2, 2. Now R2 changed to R2 minus 5 by 2 of R3. So 0 minus 5 by 2 of 0. So this is again 0. 1 minus 5 by 2 of 0 is 1. 5 by 2 minus 5 by 2 times R3, that is 1. So 5 by 2 minus 5 by 2 is 0. Now this part is important. So minus 5 by 2 minus 5 by 2 times 5. So whatever is there in R2 minus 5 by 2 times R3. So this is minus 5 by 2 minus 25 by 2 minus 30 by 2. So minus 15. Similarly here 1 minus, so whatever is there in R2, 1 minus 5 by 2 times minus 2. So this is 1 plus 5, 6. That's 0 minus 5 by 2 times 2. So minus 5. Now as you can see in LHS we have got the identity matrix. So I is equal to some matrix into A. And as you know, if we multiply a matrix with some other matrix and if we are getting an identity matrix, whatever matrix we have got is the inverse of A. So this matrix is A inverse and this is our answer. So this is very important question. You are going to get a question like this in your board's exam. So let's stop here. Thank you.